getting started here. So thank you, everyone. Good morning. Welcome to Postgres Rails 6 MultiDB. We're going to talk about some pitfalls, patterns, and some performance today. So just a quick show of hands. Who uses Rails and Postgres together? Just about everybody in the room. Awesome. Who's on the latest and greatest of both? So Postgres 11, Rails 6, or Rails the latest 5. Rails latest 5, we'll do that. Yeah, all right. No, we have 11. We'll get to that in a minute. So with Rails 6, they added full support for multiple database abstractions. So what that does is that allows read and write databases to be specified at every level of your Rails application, in the rake tasks, in your active record models, even filtering API requests down to the DB selection. So how exactly does that interact with Postgres? So before we jump into it, I want to give a quick thank you to the Rails contributors that were on this project. There's a ton of work that went into making this possible and a lot of refactoring, so thank you to the Rails contributors. Just a little quick blurb about me. I've been a Heroku data engineer for about 3 years now. Been primarily working on Sinatra and Ruby on Rails applications, and I've worked with a slew of NoSQL and SQL databases, but over my tenure at Heroku, focused on Postgres, specifically with high Postgres traffic and large data sizes and data growth. So some phrases you'll hear me use in the talk are some familiar with Postgres. You may know these, but if you need more information about them, you can come see me after. Bloat, vacuuming, partitioning, sharding, replication statistics, caching, and connection pooling. So we're going to use the premise here. I gave a talk last year about Postgres 10 performance, and I talked about having a self-help life coaching business. And so it's booming right now, right? It's doing great. There's tons of people into a lot of that uplifting, motivational success in quotes and speaking. So some of it revisited. We have customers that have some marketplace for selling things like mugs with great quotes, to pictures, to framing images, things like that, and shared areas of interest, favorite quotes, TV shows, movies, foods, you name it. So now we're up to millions of users and hundreds of millions of updates per day. But now we're at this size. Customers are doing a lot of complaining because they have seen a lot of slowdown in the platform. Profile updates take a really long time. They can't update their addresses for new shipping, and they want to upload their own quotes, and they're taking forever. So doing some initial analysis, we found that the characters that we track for favorite TV show characters and movie characters, it's growing really fast. There's amazing shows out today on every single platform, you name it, and we're just growing, can't keep up with it. So what can we do to speed this up? Well, we can talk about moving some of the more expensive reading queries off to a replica. So what that'll do is that'll alleviate a lot of the worst of the traffic on the characters table, which seems to be causing the majority of the slowdown. And there's a little bit of a hiccup here, which is I want to use it in my Rails app directly, so it feels like there's kind of a cap. So let's talk about that cap, specifically the CAP Theorem. So there's 3 specific tenets of the CAP Theorem, which are consistency, availability, and partition tolerance. And the theorem states you can achieve only 2 of these 3 at any given point in time. You can try to compensate for that lack of a third one, but truly you'll never be able to fully achieve all 3 simultaneously. So what this does is it helps identify critical failure points, increase the overall responsiveness, longevity, and stability of your applications. So how do we translate that to Postgres and Rails? So this character wants to make it in there, right? I'm pretty sure he wants to be included with all the other crazy characters. So the characters content here is hundreds of thousands of TV shows and movies, and each one can have many, many characters. Some have hundreds, some have thousands. Anyone Game of Thrones out there will know that it's hard to keep track. They're all dead. The varying information about each character or each show can have a huge impact, and we primarily control that updating right now. Characters per show or movie will be updated similarly, so we upload that information. And depending on each character or show's popularity, or even movie's popularity, depends on how often that information is queried. So what can we do to speed it up? Well, since Rails 6 introduced multi-DB, we can add the ability to have Rails intuitively understand how to split reads and writes. So let's actually jump into what that looks like. What do we need to change in your Rails environment? What needs to be defined? How do I look at each individual record? So to start, here's a base example of splitting out just the characters. So say characters is a URL that we have defined on your application in config vars. You can also create a replica in a similar fashion and define it at the database YAML file. Okay, now we've got Rails to know where to look, but how do you get the active record to look at it? Well, thankfully, that's also been updated to be fairly simplistic. The database connection definition also not only allows you to establish it at the single table inheritance, but it allows you to inherit that connection strategy through your children classes. So TV show characters and movie characters will now understand how to do that too. So having the base model define the connection strategy is a really robust, simplistic solution. And since the child models will retain that strategy unless they're overwritten, it enables us to prioritize workloads very effectively. So this gives us a lot of performance in prioritizing write throughput versus read throughput for querying that information back. So we can also specify a role for a very specific, if we want something, say, like a random TV show character as the start of your day. You can specifically ask for that single one first and only specify to look in the reading area. So if you know you have certain operations you don't even want it to go through trying to figure out the write database or the read database, you can have it do that. But some strange things have started happening here. The latest characters we've uploaded from our upload pipeline don't seem to be actually getting uploaded to the database, or they seem to not be coming back. And my customers aren't seeing their latest characters added to their favorites. So what's going on? Well, I think we've hit a pitfall. So we can look at some interesting information. You can look at this via your Postgres internals, or if you're on the Heroku platform, you can use the CLI, and we actually give you this information up front. So we're behind by a large number of commits on this read replica. So what is that follower lag? What is that issue with the read replica? So for those who may or may not be familiar, Postgres sends a lot of write-ahead log to replay the changes. More traffic to the primary, the more write-ahead log gets generated and has to be sent to the replicas to replay. There's other factors that can go into slowing down the replay on the replicas themselves. And there's too many to list here, but that's a very difficult topic which we'll start to digest as we go on. So some basic things we can look at up front. Are we missing any indexes for the replica? Or what's our connection usage look like? Or how are the database resources? So optimizing Postgres for reads versus writes, especially on indexing, looks really different, right? The size of the data sets can even change your query plans. You could have an index that works just fine for writing, but ultimately when you move it to the replica, your replica can slow down and do some kind of strange things. Caching also changes the effect on the DB and can affect the performance too. So let's talk about explain and analyze first. So this is going to be a good way for you to identify when you have some queries. Postgres in the pSQL console can actually show you what your active record SQL queries are actually doing and how they actually perform. So a basic example when we take a first look at this is we want characters from a given show ID. This is a pretty common query, right? Like we have a TV show we want to look at, and we want all the characters for that show. But we're missing an index here, right? This is a pretty basic one. So you'll notice a few different things here where the number of rows returned is a lot. That's almost the entirety of the table, right? We're going through the entire table scanning this because it's not the character ID, that's the show ID. So if you have to sequentially run through the entire table, obviously, depending on how big your table is, it's going to take a long time, which is why you see sequence scan. So some things to look out for when you're looking at explain analyze are the sorting method you're using. The sequence scan are going to be the least performant of your types of scans. Groupings will also affect that, and conditionals will also affect that. Surprisingly enough, there is internal ordering as Postgres constructs the data set, so conditionals and groupings will affect that too, depending on how complex your queries are. So things that you'll want to look for or try to favor are bitmap index or heap scans, or index only or index scans. Those are going to be faster because indexes are heaps. They're not going to go through the entirety of the table. They're going to traverse in log n time over the subset of the data set for the pointers. So a different example when we've actually added the index, you'll see that it's a huge improvement, right? We've gone down to only a few hundred rows, like 106 rows, and a significant decrease in query time. And there's a lot that can go into that. But indexes aren't the only thing, right? I've checked the indexes, and my lag is still gone. We've caught up now. I'm not above my connection limits, and my query analyzer doesn't show me anything really intuitive. So now what? Well, we might have hit another pitfall again. With our databases and our customer base being so big, our write-heavy primaries are just slowing things down. We're adding tons of quotes every day or updating quotes every day. And customers want even more interaction with our inspirational quotes or favorite quotes of our characters. And they're complaining that we don't even have every character that they want to quote. And so they want to be able to add those features too. So now we have to look at what's going on in the quotes table. So the volume of heavy usage queries can slow the replay, but the volume of write throughput, it can also do that too. We're writing just that much more into the write-ahead log that's just going to give you a larger volume of things for the replicas to replay. The bigger your connection churning or pool saturation as people disconnect and reconnect can also affect that. It means the actual OS of the database can be affected. So there's also a third thing where the general size can start being an issue. Even having the database re-indexing, if your indexes are not very efficient or performant, can cause a lot of problems. So we want more ways that users can interact with their quotes. And we want to be able to find a way to segment quotes off or figure out what else we can do. Quotes older than a week just fill the DB cache. Like, people actually don't really care about them or look at them that much upon our inspection. But the DB has a cache? So yeah, databases have caches. Most of the stuff that you're looking at when your Rails application is querying stuff is actually querying your database's memory. It's not going to disk. Very rarely, if your database is set up correctly, should it be going to disk. Every time you're going to disk means that it's an exponential decrease in your performance. So writing a lot of new data can also churn a lot of your memory. Your database caches will eject information the more new information you're putting in and the more you're reading out. The larger your data sets are and the more length of time has passed over your data queries, you're just going to keep churning through your memory, which means there's more opportunities for your queries to start doing what's called disk swapping. And I won't get into that too much, but that's basically how your memory in your database gets moved to temporary storage on disk, which slows everything down a lot. Indexes are still mostly held in memory, but they're mostly pointers. They're not full pieces of data. So you still have to go back to the disk to figure out what you're looking at. And indexes that are on tables of high rate of change can also affect the load, meaning that your database has to change the write-ahead log to enforce that information for the indexing as well. So I can feel my own chest tightening a little bit about this. What can we do about that? What can we do to breathe a little easier? Well, thankfully, Postgres had PgPartman for a while, and with the advent of Postgres 10 and 11, partitioning is now native in Postgres, so we can start partitioning the quotes table. So partitioning is a good way to move less access data off and to let the DB caches breathe. Default partitionings were enabled in Postgres 11, so Postgres can do some auto magic to kind of infer how some basic structures of your data look like, using things like unique indexes and primary keys and things like that. The advent of partition-level aggregation can create deep parallelization in queries too, which means it's a lot faster to jump between segments of the table itself because Postgres views it as different tables that it knows how to collate at the end of a query. So an example of this is we can attach a partition to the quotes table that we never had before, and from there we can add more of these. So if we know that we have an explicit range here from July and August of 2016 where we got a huge bump of quotes, we can actually partition that off. And you can partition them based on year and month for a lot of your older quotes and values moving forward, and you don't necessarily have to drop them. You can leave them. Postgres partitioning needs its own talk. That's a whole different other topic, and there's a lot of nuance there. But if you want to come learn about more of Postgres partitioning, come and talk to me afterwards. So now that we have some ease of using the quotes table, customers are still asking for being able to use their own characters that they've uploaded and their own quotes. So since we have a separate table for characters now and a separate table for quotes with all the partitioning, how do we handle that? Characters have also been moved off to their own database, right? So now we want to see how quotes and characters interact from the primary and their read replicas. What does that look like from a code perspective? But I mean, we're still having a little bit of sluggishness in querying quotes. There's a lot of them. So yeah, that quotes table blew up fast. Yeah. Well, what if we do something like this? How can we handle that data growth? Well, we can shard quotes out. With Rails multi-DB, you can actually have the table defined in its own database, which means we can move the entire table out. So we actually get some separation of concerns in DRY principles at the data level by sharding our databases for the pieces of data that are very large. It prioritizes the critical functionality of the main database for user access and logins and profiles, while still allowing all the functionality of all of the user source quotes and characters that we want to give them. So moving quotes to its own DB also gives a lot of relief to quotes and the original Rails app. Characters are flowing now in a consistent fashion. Other tables are performing much more consistently as expected. So an example of how this could be done is we can actually define a different quotes table and a different quotes database to move everything out. And in Active Record, we can actually tell it to just create the quote and the character. What that does is that allows Active Record to intelligently split and prioritize and direct traffic to where the tables now currently reside in the different databases. What's happening in my Rails app? All of a sudden, everything's going haywire. My Rails queries are taking forever. What's going on? Well, I think we hit another pitfall. Rails is slowing down because logic in the app can repeatedly end up in database loops. We're now making a lot of different network hops because we're jumping to all these different databases. We're different quotes database for reading and writing. We're different characters tables for reading and writing, different user profiles on a third database. Joins have to be done at the Rails layer, not the DB layer, which means because our data is not co-located anymore. And we're reconnecting to all of these different databases a lot of different times, and that's really slowing everything down. There's also this issue of how the query cache is performing. Because the caching, even in the query cache, is having to query the same table multiple times, we're blowing away query caching in how we query from Rails out to our databases. Our database caches are also churning additional slowdowns. Something to really consider is that looking at your 95th and 99th percentile queries, those are going to be the ones that stop your database in its tracks. 9 times out of 10, more often than not, you're going to be seeing that these percentiles of these queries are going to be 1 or 2 queries blocking the entire DB. And that's going to bring everything to a screeching halt. Yeah, I'm getting exhausted. It feels like I'm playing whack-a-mole up here. Network latency is a really hard problem to solve. And it's not talked about in the CAP theorem, but it is mentioned in a theorem that was done not too long after that called PaceLC. And the PaceLC theorem talks about when partition tolerance is critical, you can choose between availability or consistency. But when we're not considering critical failures of partitions, you have to choose between latency or consistency. So it feels like when we look at it from that perspective and what that means for me, latency is our biggest concern now. We've moved all of our concerns down to the network layer. We're not even at the database anymore. How do we avoid all these round-trip network jumps? How do we minimize the networking issues or these slowdowns or even network blips? And how do we maximize the size of our data and its usage given this limitation? Our consistency is not our problem now. It's the speed of which we deliver information to our customers. So some things to consider. What connection pools are you talking about? Are you referring to database connection pools or the Rails connection pools? Are the Rails servers actually using connection pooling properly? Are they not over their attempted limits on the app servers or the DB limits for the DBs? There's a lot of times where you can configure Rails to try to establish connections to any one database. Now, if you've spread out your databases into 5 or 6, now you have a bunch of different databases. You have to go hunt for which limit are you talking about. So are they all, what about the database connection pools? Are they all going directly to Postgres? Postgres doesn't have native connection pooling. Do you have connection pooling set up on your Postgres with something like a PgBouncer? Is Rails saturating the DB limits, or is it a Rails-specific issue? Are your connection pooling settings set up correctly on your Postgres databases? Are they set up on all of them, including your read replicas? They may not be. Why do my caches seem useless? Well, which cache are you referring to? Are you referring to your query caches or your database caches? If you're referring to your database caches, is it your writable database or is it one of your read replicas? Which one is churning more and which one's causing the slowdown in your response times? More often than not, people think that their write database is having the issue with caches, but a lot of times it's the read replica that they're using. And it could be one of them. You might have 4 or 5 set up for a single write database. And if you're looking at one read replica, make sure it's the right one. So if we talk about how big your caches are, because we want to talk about data sizes, we have to address the size of your data in relation to the caches on the database. So I talked about using disk swap earlier. So this is what I wanted to bring up again, which was Postgres will actually try to intelligently move some of the data you're querying temporarily to disk. It'll write temporary files it cleans up afterwards and hold them there before returning the entirety of the data to you. And it may do this a lot. You do need to know if you're using too much of your disk just to do the reads, before you realize that you also need to optimize for avoiding those types of scenarios. The caches will cache whole records if you're not using indexes. It won't just cache a pointer. If you're using swap, it'll point to an entire record written onto disk too. So you now have a problem where your disk growth on your database is also growing the more you query it, which is an additional problem you may need to solve. Postgres can stop accepting connections entirely or stop even responding to requests. You may have a connection open, but it'll say, nope, I'm out of memory, too bad. Or I may not be available, I'm doing something else, I'm too busy. I may have even fallen too far behind on my replication and I need to stop and recover. There's a lot of scenarios where your Postgres can shut down because you've overburdened the traffic or the way you haven't optimized for your workload. So what's another area to look at? Well, how are your resources on your app servers, on your Rails application servers going? Are they running out of memory? Are they running out of connections? Are they overutilizing CPU? Are they even trying to use some disk on there? Are they trying to save a bunch of information separately elsewhere on the application server? You may not even have enough space on the app server to do what you want. What's there left to spare on your DBs? Similarly, as I discussed before, memory is a hot commodity, followed quickly by the I/O, how fast you can access that disk information, and CPU. CPU is going to be the other big tell in your idea of if you're using swap. You'll see a lot of CPU wait as the statistic that you'll look at to see if your CPU is trying to wait for your disk. It's just going to sit there and spin cycle, and it's not going to accept anything else. So you're going to be burning CPU hours just trying to wait for your disk to free up, which could be extremely costly. And of course, last but not least, am I out of connections? So it feels like there's a lot of things to look at, and there's a lot of things to consider. But there are some helpful ideas and some food for thought that we've had and grown over the years at Heroku and working with the Rails. So apps should have safety measures. Things like maintenance modes, feature flagging, and circuit breakers when you find that things are going wrong are certainly things to help protect your uptime and keep you running. These are really important, especially for running experiments, rolling out new features, or even when you see other issues like critical hardware failures or parts of the network are going down. It seems like there's every other day, there's always an issue with a public IP that, a public IP administrator that's always having ISP that's going down, like Dyn or something out of AWS or out of any other cloud provider or local host you're using. So having circuit breakers to turn off those features are going to be really critical to maintaining your uptime. Data services should have thresholds. You should be tracking that information and knowing that you have a certain limit or a buffer zone of where you need to react. Tracking the utilization so you leave room for yourself in case you have traffic spikes, in case you have slowdowns, in case you're running a process that you don't expect to hurt you as much as it does. Think back to when we're uploading characters and TV shows and content, even internally. You wouldn't expect that to cause an issue on a characters table, but it absolutely will. Especially if you have to load up a lot of data really quickly, it can cause a lot of problems for your customers down the road, and you need to be able to stop it. Web traffic spikes, if you're gaining popularity, can also have an equal effect. So you need to account for some growth even as you're building your plan moving forward. And putting a plan into place when those events occur or when you're losing that buffer and that threshold limit is occurring is a really important first step into understanding what your options are. And of course, there's always new strategies coming out. There's always new ideas and new ways to account for all of the changes in your traffic. Whether your data is changing, whether your users are changing their behaviors, there's always ways to evaluate new strategies, and I would highly recommend you evaluate new ideas early and often. Architecting services is a start for the principle of least privilege, which means they only have access to the things they really need, not everything under the kitchen sink, is definitely a good start. identifying how you can lower the scope of your services to make them a little more lean. They may be doing too much, right? They may be doing a lot of things that they don't need to be doing, and you can segment off to the primary ownership of another part of your Rails app or another service entirely. Some easier things that you can do today. Start breaking up your monolithic code. Get rid of your God classes. Get in there. If you're scared of a class, I highly recommend you go in and you start attacking it now. The more you fear your own code base, the more it's going to instill that fear to avoid it and let it rot. Identifying those critical real-time applications versus non-real-time or fault-capable services, things that can be eventually consistent, can also help you determining what's really urgent to go fix. So I would highly encourage that idea to understand what can you live with a little bit of lag or some caching at the content layer, or giving customers a view of something that may be 5 to 6 hours old. They don't need the upfront like refresh data today. And even refactoring your data relational restrictions. I talked about earlier how your conditionals and your constraints and your groupings can affect your database performance. They may not need to be there anymore. They may be holding you back from achieving greater performance or even enabling new features. So with that in mind, I'll talk a little bit about what Heroku is offering today, and then I'll open the floor for any questions. So we've opened Postgres 11 and generally available. We've made an announcement earlier in the year, but I want to reiterate it here. Postgres 11 has a lot of these really helpful features that you can use today. Things like stored procedures to bring them into closer parity and compliance with SQL standard. Partitioning and optimization features, extreme advanced parallelization, have huge drastic improvements on performance. And you can learn more about it in our blog. We also continue to offer our curated analytics, so we can query all that information that you see in Explain Analyze in those caches, and we deliver it in a consumable, readable format. We also expose that information in logs, and we also give you that information on how to look for it, even just using the pSQL terminal in Dev Center. So please go look at those. Those are out there for free and anyone to use. And we still talk about PgBouncer, talking about managing your database connections. Right now, we do still continue to offer the PgBouncer connection pooling beta, which lives on the servers with the databases to prevent them from this exact problem of having connection issues. We, right now, only allow transactional connection pooling. Session pooling has its limitations and has some pitfalls. I know that Rails prefers session pooling, but there are problems with trying to get out of those 95th and 99th percentile issues that stop and turn off a database. So that's one of the reasons we picked that. You can use it to achieve better visibility on your connection statistics, adding your guardrails. And this is really great for asynchronous workloads, especially if you have a big queuing system or a data upload that you need to do. We still offer this in 9.6, 10, and 11, but we also continue to maintain the client-side PgBouncer build pack, which you can maintain on a separate runtime or separate application server in front of your database. So please go check those out. Please read up on them. They're free. And I talked about adding guardrails and ways to fortify your applications. We've had a couple other of our coworkers openly blog and talk at RailsConf and other conferences. And these are a couple of them that you can go check out. We've also added additional monitoring with data.heroku.com, a graphical way to look at that information on Postgres in Heroku with all of the analytics of what are your slowest queries, what are the ones that are taking the most I/O. So please go check those out. And thank you so much for attending. I'll take any questions. So the question was, if you partition your table, do you have to make query changes? If you're querying the default table, the answer is no. If you're trying to optimize for specific older date times, you would have to figure out a way to programmatically tell your database to go look at something that's a lot older. Rails does let you identify raw SQL. So you could tell it to look at the same database, but look at a different partition. if you wanted to look at historical things. Like say you wanted to do the quotes throwback, you would be able to use a random generation to create the string and execute the raw SQL. Any other questions? Back there.
You mentioned when you define your databases, Rails starts doing the joining on the Rails layer.
Yeah.
What support does Active Record have for joining tables and everything?
OK. So the question was, what support does Active Record have for joining the tables at the programmatic layer? The short answer is that's one of those things where you would have to define it on your own. So because you're moving that specific relational information to your Rails app, Rails doesn't intuitively know how to do that up front. You would have to try to construct that information as you're querying it back. Because your Postgres databases don't know how to do that, and your Rails is writing raw SQL under the hood. You would have to get each data set, filter it a certain way, and then collate the information at your application layer. So it puts additional stress on your Rails app. But you would have to do that at the Active Record layer. Over there.
Do you have any suggestions on how to load test this?
The question was, do we have any suggestions on how to load test?
And also, how do you make the tests independent from Rails, for example? I mean, do you test directly the Rails app or the Sinatra app or straight to the database?
OK. I'm going to try to reiterate, and correct me if I'm wrong. So the question was, how would you performance test this, and how would you be able to define whether or not the issue was at the Rails app layer or the databases layer? There's a few different ways you can do this. One of which is you can figure out the complexity of your Rails code. So how many times you have to jump through the same queries, and that's something you can do via RSpec or even API integrations. There's a great gem called Airborne that can do that via an API layer, especially if you're using Rails API. If you're looking at load testing on your database, unfortunately, the only way to do this is in a mirrored environment, in like a staging environment that the hardware setup is identical to your production environment. And you would have to be able to have some similar setups of like graphical interfaces with logging of seeing where the discrepancies are. I know there's a lot of tools and third-party vendors out there, like Labrado will do that log aggregation for you, or New Relic is very popular. But that would be the closest way to do it, to give you an accurate representation, because doing it any other way is going to not really give you one-to-one results on how your production environment would work. Does that answer your question? OK. Yeah, so the question was if Rails actually does more than just the reading and writing, or if you have to protect yourself and figure out all of these different strategies on your own. The answer is yes. Rails does not do anything more than help you define connection strategies. All these advanced topics, you are correct, are going to have to be done by the engineering team and the development team to be able to do those things. But thank you so much, everybody.